Alright, today we're going to solve the last exercise from the topic Newton's third law of motion, symmetry in forces. And, well, here we have it. A brave but inadequate rugby player is being pushed backward by an opposing player who is exerting a force of 800 newtons on him. The mass of the losing player plus equipment is 90 kilograms, and he is accelerating at 1.20 meters per square seconds backward. What is the force of friction between the losing player's feet and the grass? Alright, just remember that for this kind of exercise, one of the most important things that you have to identify is the direction of the acceleration. According with it, we will see the sign of every force involved here. So the acceleration, and by the way, I'm considering the inadequate rugby player as the red one, so the green one is pushing the red one. So the acceleration is on that way. Now, we have the force exerted on him that is on that way. We're gonna call it capital F. We already know it's equal to 800 newtons, and always the force of the friction is opposing against the movement. So I'm gonna draw it here. Here is the friction of the feet player and the grass. Remember that this kind of shoe has pointed things that allows to the player to grab on the floor. So this is going to be the force of the friction that we don't know. Alright, the formula that we're going to use here is the Newton's second law of motion, which states the addition of all the forces is equal to the mass times the acceleration. And what are all the forces involved in this exercise? Well, we only have the force of 800 newtons on the player and the force of the friction. So let's add them. We have force on the losing player plus the negative of the friction, and remember it's negative because it's against the movement, equals the mass times the acceleration. We have all of this data, but we don't have the force of the friction. So let's replace all of those letters by the numbers. The force is equal to 800 newtons. Here we can say positive multiplied by negative is going to be negative, and that is going to be equal to the mass, 90 kilograms, times the acceleration. The acceleration is equal to 1.2 meters per square seconds. Alright, as you can see, our unknown is the force of the friction, which, by the way, is negative. One of the easiest things that we can do is send that unknown, which is negative, to the other side, and then it will be positive. So here we have 800 newtons equals to, alright, 90 multiplied by 1.2 is equal to 108. 108 newtons. And here I'm going to place as positive the force of the friction, since it changed of side. Now the 108 newtons, which is positive, goes to the other side as negative. That is 800 newtons minus 108 newtons equals to the force of the friction between the feet player and the grass. 800 newtons minus 108 is equal to 692 newtons, equals to the force of the friction. And that's it. With that, we have solved part A. Now what about part B, that says what force does the winning player exert on the ground to move forward if his mass plus equipment is 110 kilograms. We already know that he is exerting a force of 800 newtons, but he has to move the losing player and himself in order to move all of that system. So we will have to consider his mass. That's why they're giving us his mass here. So let's see what we have to do here there. Okay, as you can see, we have the same direction for the acceleration, and we have the force of the friction again opposing against the movement, and here I have represented the force of the player on the ground. But as you can see, both forces here are negative. It's going to be a little bit complicated, and to make the things easier, I'm going to use Newton's third law of motion, and that means that the force that the winning player is exerting on the ground is the same force that the ground is exerting on him, but with the opposite direction. I'm going to call it F, the force of the ground on the player. For short, FGOP, force of the ground on the player. And with it, I'm going to have, well, by the way, from here now, I'm not going to work with this one because it's going to be negative, and that makes the things a little bit more complicated. I'm going to work with this one, which, by the way, is equal to the other one. So I'm going to work with the force of the ground on player. And when I'm going to use the Newton's second law of motion, I'm going to use F of the ground on the player and the force of the friction. That's it. So it's time to use the Newton's second law of motion. By the way, this is part B. And let's start. We have to add all the forces involved. That is FGOP plus the negative of the friction equals the mass times acceleration. Alright, this time we don't have FGOP. We have the force of the friction. First of all, positive multiplied by negative is negative, and the force of the friction is 692 newtons minus 692 newtons equals 2. Be very careful right here, because this time we're going to consider the mass of the winning player and the mass of the losing player, because after all, the winning player has to move himself and the losing player. So let's do it. We have to add 110 kilograms and 90 kilograms. And that will be multiplied by the acceleration of all that system. That is 1.2 meters per square seconds. Okay, sorry about that of a second. Here it is, a little bit better than that one. Okay. And here it is a better point. Okay, so let's try to solve all of that. FGOP is equal to, I'm going to leave the 692 here just for now. 682 newtons equals to 110 plus 90 is equal to 200 kilograms times 1.2 meters per square second. And then 200 multiplied by 1.2 is going to be equal to, by the way, I'm going to send this time the 692 to the other side. So 200 multiplied by 1.2 is equal to 240 newtons. Remember, kilograms times meters per square seconds is equal to newtons, plus 692 newtons. Finally, (240) plus 692 is equal to 932. By the way, the exercise is not asking us about the force of the ground on the player. It's asking us about the force of the player on the ground. But according to Newton's third law of motion, that force is equal in magnitude but opposite in direction. So the force of the player on the ground is equal to minus 932 newtons. Okay, so here we have used the Newton's second law of motion at the beginning and also here, but at the end we use it again, the Newton's third law of motion. Okay, that's it for this video. I hope you could understand it. I'll see you in the next video with one new topic. Goodbye.